Hey guys, how's everyone doing? Welcome to today's first lesson. We're just going to get straight back into it, and we're going to talk about something new today. So we're going to just talk about, or I guess it's really not new, we kind of gone over it before. We're going to go a little more in depth. Pythagorean theorem. Um, so for Pythagorean theorem, okay, we have just a normal triangle, a normal right triangle, and we have legs of A and B, and a hypotenuse of C. So when we go for that, so we're going to say this now. A and B are both are called legs, okay, and they're always going to be attached to this 90 degrees right here. So as you can see, this 90 is right here, okay, and they're always attached to it. C is what we call the hypotenuse. Called the hypotenuse, okay, and that's always the longest side, and it's always going to be positive. There's no way C can ever be negative, and I guess we really won't get into that much, but for other people that are looking at this, C is always a positive number, okay. The general equation we have for Pythagorean theorem is a squared plus b squared is equal to c squared. So that allows us to solve for any side, any leg, or the hypotenuse, depending on the situation, okay? So let's look at a few examples. So number one, we have a triangle as such, 8 and 13, right triangle, and we have some hypotenuse of x. So we have these sides. Our legs are 8 and 13, and our hypotenuse is x. So let's go ahead and put these terms into our equation, okay? A and B doesn't really matter. They're placeholders, okay? You can choose whatever one you want to be, okay? They're just legs. So we're just going to go straight forward into it. So 8 squared plus 13 squared is equal to x squared. Alright, so using our calculators, we'll put in 8 squared, and we'll end up getting 64. Okay, and that's plus. Put 13 squared in our calculators, we get 169, and that's still equal to x squared. Now, add those two numbers up, we get 233 is equal to x squared. Now we want to solve for x. Okay, we want to solve for x. So in order to do that, we have to get rid of this x squared. So what we end up doing is we take the square root of both sides. Okay, this will allow us to solve for a single x value of this function. Okay, and we end up getting, after you plug this in the calculator, plug the square root in, x is equal to 15.26. Now, typically when you take the square root of x squared on both sides, you do get two values. You get plus or minus. But we already established that the hypotenuse has to be positive. So there's no way we can have a negative value for this. That's why we end up saying x is equal to 15.26. Okay, and that's just as simple as it goes. Right? Let's look at another example. Okay. How about one where we don't solve for the hypotenuse? So how about this one right here? Okay, and let's go with 15 and 17. Okay, so 15 and 17, so I'm going to plug those in our cat, and we're going to write our thing. So this is our x term. So once again, my legs are attached to it, and my hypotenuse is away. Okay, hypotenuse is always across from the 90. So I'll rewrite my equation. 15 squared plus x squared is equal to 17 squared. So now we need to simplify these terms. We need to find what 15 squared and 17 squared are. So we're going to plug those into our calculator. So 15 squared gives me 225 plus x squared. And 17 squared gives me 289. Now we're solving for x squared in this instance. So we need to subtract 225 from both sides. And we're left with x squared is equal to 64. So once again, we want to solve for a single x value. So we take the square root of both sides, and we end up getting x is equal to 8. Alright, so that's it for today. Like I said, this is just a simple lesson. I'm not going to do anything too much. Let me go back to my face cam. Like I said, I'm not going to do too much. Okay, today is the first portion of Pythagorean theorems, so they're just standard problems solving for a leg or solving for the hypotenuse. As you can tell, it's not very difficult. Okay, just refer back to this video anytime you need help. Okay, tomorrow we'll go into a little more complex situations of problems, and they're not complex in the way of just crazy stuff going on. It's just maybe they're not a triangle anymore, they're a square, and how we can break that apart into being triangles or rectangles and things of that nature. Okay, hope everyone has a good day, and I'll talk to y'all tomorrow.